Fingers, please. Okay, this is the last in my series on 3D printing. It was never intended to be a tutorial, but I wanted to give viewers an idea of how to process, how the process works so that the modeler can decide if he wants to pursue this technique on their own. In this presentation, I'm going to be showing photographs of various 3D printed models I've built. Most were constructed with Shapeways fine detail plastic. A few were printed on my Illigu Mars 2 with Cereatech build resin, and I'll point those out. In a few instances, I can make direct comparisons between the two techniques, and you'll see those too. There we are. The first one I want to talk about is the station at Ronceverte, West Virginia. Ronceverte is French for Greenbrier, for the Greenbrier River that flows nearby. Ronceverte sits at the base of the eastbound grade over the Allegheny Mountains. It was the original helper terminal for the grade, but as larger locomotives came into use, the helper terminal was moved to Hinton, where they had much more space and much better mechanical facilities. So on my layout, Hinton and Ronceverte are sort of mushed together, as I have nowhere near the space to even make a condensed version of Hinton. Everything in this model that you see, except for the platform, is 3D printed. I built it in Shapeways fine detail plastic as an experiment to see what could be done with 3D printing. In an earlier segment, I pointed out all the problems I have with this model, and there was a lot of them. Some can still be seen, and especially in the curvature of the second story roof there. That was a real mess. And the main takeaway from this is make the components as thick as possible to minimize warpage. A lot of these components here were quite thin, 0.5 millimeter or something like that, and that is not the way to do it. Another model I worked on, I've worked with, is the Roundhouse at Hinton, West Virginia. This photo was sent to me by a friend. It is the only decent photo I have of the Roundhouse. It was taken shortly before it was demolished. Bill Simonton made an exhaustive study of the Hinton facilities and generated many detailed drawings of the various structures. And I used his drawings to develop this model. Over the years, the prototype was rebuilt many times, modified extensively. As a result, you have this very strange roof line there. You can see in this photograph, you can see 4 different existences of this structure. And it's quite a challenge. The louvers on the monitor roof were particularly difficult. These guys up here, that was a real problem. And all the windows are custom built. These are this shows the backside of stall 17. This is one of the long stalls that was built for the Alleghenies and the 2882 Simons. It's a good example of custom built windows. Now, all the window components were cast from masters that I cut on my mini mill. And it was a complicated process. I'm not going to go into that. The red color is close to the as-built color for the C&O wood structures, but it still needs some heavy weathering. The red components are pigmented epoxy. Pigments were from Dick Blick Arc Supplies and were hand milled into an epoxy resin. The pigmented resin was used to cast the heavy frames on the side molds, and another set of molds was used for the window sashes. Finally, the sashes were mounted in molds that were cut to half their depth. So they actually had insets where the sashes would sit into the molds. And clear epoxy was poured into those molds and then capped with a release sheet to create the windows. This is the smokestack on that chimney. Again, this is the cap stack and base are all 3D printed. The connecting rods are brass wire. The window frames and louvers are cast in a single part. And then the from a mold, it's this is a 3D printed master from Shapeways. The windows are my usual double cast epoxy, and the wood truss. Now this is pretty extreme. The wood truss seen through the window is an American basswood that I milled from a tree I cut down when we were building our current house. So I have a lifetime supply of basswood. The roofing material is 00 silica sandblasting medium, and it's just glued down with flat black interior paint. Now, the Roundhouse doors, they're all C&O Roundhouse interiors, floors, beams, the whole thing. We're all painted white to maximize the light inside. Now, this shows a couple of things that are unique to C&O. The Roundhouse doors were extended almost out to the edge of the turntable pit as the things were being built and modified. The original doors were barn doors, and they would close in this way, like this, forward toward the pit. When the big Alleghenies and the 2882s came in, they had to extend a few of the saws, and rather than keep these barn doors, they put in roll-up doors here. So you had different doors for those extra long stalls, just to clear the tender. Another model that was a common site on the C&O were the Pogue water columns. And these things were really big. The top of that base here, that's about 6 feet high. Overall, they were about 15 to 16, 18 feet high rather. And all that depended on the needs of the railroad. Was they just changed the length of this standpipe here. Now here you see two of my models. These were both printed from basically the same file. The one on the front, the white one, is unpainted, and it's from Shapeways. The one on the back is printed on my Iligoo printer. And because you have all those supports, you notice that I put the supports where you can't see them, because they do leave a little dimple. You have to be careful about where you allow those supports to be present. This is the final model of it, and it's painted black. I'm going to have to go back and redo that. It turned out to be a tiny bit too short for the H8 tender, so it's going to have to be on a little bit higher mounting block than that. Another model that I've worked extensively with are the C&O cantilever signal bridges. These are classic C&O structures. Oh, here the model. This is the model of it. This is the small signal bridge. The bridge structure is printed. The main, all the lattice work and all that stuff is all printed. The signal masts and faces are castings from epoxy castings, and the maintenance platform, ladders, railings, were all etched in 0.4 millimeter phosphor bronze by PPD Limited in Argyll, Scotland. If you have any etching you want done, go to those guys, because they're really are the best in the business. They do an excellent, excellent job. I've never seen anything quite as good as those guys. This is a comparison between the two small signal bridges. The one in the foreground is printed on my printer. The one in the background is Shapeways. And there's some small differences. You can see maybe the Shapeways rivets are a little bit bigger than these. They're printed from the exact same file. There was just the same STL file that in both cases, but you can see some slight differences. As far as I'm concerned, they're very comparable. There's not much to distinguish between the two. The large cantilever bridge, I have not installed any of these, and this is just the basic framework that I printed. It's again a Shapeways print. And one of these days I'll build one. This is a small cantilever bridge. It's installed at my Coal Creek interlocking. And I think it looks pretty darn good when it gets on the layout. Now here's an old model I built many years ago back. Oh gosh, I can't remember. This is the clock tower on the Wilmington, Delaware, Pennsylvania Railroad Station. Back then I was doing freelance and this is my hometown station. So I said, let's build a model. And I built a complete model of it, full scale. And I just used this, brought this in to show the brickwork, because that's the next thing I'm going to be talking about. I used design preservation brickwork for the base part, and everything else is hand carved. And we finally made I made a master for it, and all four sides were cast from that master. Now here we have another example of brickwork. The main sheet there is N-Scale Architects Flemish bond. The round rosette up here and the louvers are single print from Shapeways, and they're fine DLP plastic, of course. This is one piece. Again, the outer frame of this was all except for the brickwork here. And I'll have to tell you that I think I may have actually carved these things in hand on my mill. But this again is my usual, what I was using at the time, multicasting epoxies for that window. Now, here we are. This is a 3D printed chimney that I built for a cabin. The White Sulphur Springs West single cabin. And as you can see, the brickwork in the corners is just fine. I showed how one or two times ago, I showed how I constructed the CAD portion of this. But you can see these bricks wrap around there just beautifully and get really sharp detail. And I wanted to compare that with the N-Scale Architect. This is the sheet plastic that they provide. Both of these were painted the same way. First, I painted a base color, in this case, brick red, in this case, a brown brick. Then we take Naples yellow and smear oil color and smear it all over the place, and then wipe off the excess with paper towels and Q-tips to leave the mortar lines behind. And I think the 3D printing is actually a good bit better than what we see here on the N-Scale Architect sheet material. I don't know I want to be printing up 2 square feet of stuff, but for small things like this, it shows up, and the corners come out just perfectly. One of the more exotic things is you can print gears. Now, this material is not suitable for power transport, but you can take these gears, and they're helical gears. I have no way of machining these things. You could take them and cast them in a material like an epoxy or urethane that would be much more appropriate for gear material. Now I'm almost done. There's one last thing we're going to show you here. It's one of my favorite video clips, and it's just sort of neat.